it's still a very, very big number. So all this interconnected, passing along risk from one side to the other, interest rate risk. Because this is essentially passing interest rate risk. So, what are we going to do now? You remember in our original formulation, we said the following. We said that the covariance in percent, okay, of a portfolio, if you remember that, the covariance in percent of a portfolio, it was going to be omega 1, omega 2. Sigma 1, sigma 2. Okay, actually, not sigma 1, sigma 2. Rho 1, 2. You remember that?
That's the covariance matrix.
That's the variance covariance matrix. Yeah. And this is, we had a portfolio made up of two assets. This is really nothing. This is exactly the same thing. If you remember us writing sigma squared P equals omega 1 squared sigma 1 squared plus omega 2 squared sigma 2 squared plus 2 omega 1 omega 2 sigma 1 sigma 2 rho 1. This is just a fancy way of writing that. Okay? And sigmas, in this case, sigmas were expressed in percent. Okay? You remember that? You remember that? By the way. You remember it?
Yeah.
First lecture. Okay. Now, we have two problems. Problem number one. This is no longer expressed in percent. Percent of what? It has a value of 0 in the beginning. Problem number two. These guys are getting more complex. Essentially, if we express interest rate moves in basis points. That's the market convention now. Interest rate moves in basis points. Okay? Interest rate variances in basis points. And I'm sorry, interest rate volatilities in basis points. Interest rate variances in basis points squared. Okay? Then, the natural way to produce the factor loadings for bonds and swaps would be what we just saw a couple of slides before. It would be to have the notional amount, the duration, the price, notional amount, duration, price, and the factor 1 over 10,000. And if it's a bond, there is a minus here, which indicates essentially that if my underlying risk goes up, the value of this goes down. If it's a swap, it could be a plus or a minus, depending on whether I receive the fixed cash flow, in which case the swap has exactly the same risk behavior as a bond, or if I give the fixed cash flow, at which point the swap has exactly the opposite behavior to the bond. So, what would this kind of matrix look like? Okay, how would you describe the value? The risk in euro amounts of a portfolio which is made up of one bond, 10 years, it's a 10-year bond. The notional amount, let's call it NB, notional bond. Let's see, it's a 10-year bond, notional amount. I think this, and it's a par. Price equals equals 100. I am long this one bond, and I am short, and I have entered into this swap, interest rate swap, which is 7 years. Notional amount for the swap, it's initially at zero cost, okay? And the 10-year interest rate is 5%. It's the sigma of the 10-year interest rate is 50 bips. The 7-year interest rate is 3%. Sigma of the 7-year interest rate is 40 bips. And the correlation between 7-year and 10-year rate is 0.9. Okay? So what could this thing start to look like? It's very simple. What were these omega 1, omega 2s initially? This would be a different way to write this. Okay? Would be the following. Sigma square P times the value of the portfolio squared, okay, equals omega 1 times value of the portfolio times omega 2 value of the portfolio, omega 1 value of the portfolio, omega 2 value of the portfolio. Okay? Suddenly, this first term in here would become omega 1 value of the portfolio, sigma 1 squared, omega 1 value of the portfolio. It's going to be, what's omega 1 value of the portfolio? This is the euro contribution of the euro value of the first stock. So it's going to be V1, let's call it V1 squared, sigma 1 squared, which is going to be the variance of stock 1 in euro squared. Okay? Now we're going to use exactly the same logic to build this kind of summation when we have bonds. Okay? So we need some way of, if in here I have basis points squared, okay, what could I have to have in the, instead of omega 1 for this bond, so that this term, this times basis point squared times this, to give me the variance of the bond position in euro squared. What's the variance of the bond position? What's the volatility of the bond? What's the return of the bond? If it goes up by, we just saw it. We just saw it in the previous if my interest rates, they go up by 1 basis point, okay, how much will my bond position go down? Remember, 1 basis point is 1/100th of 1%. How much will it go down? Let's say that my bond has notional amount of NB. It has a price of 100, so its value is NB, and it's a 10-year bond. What's the duration of the bond?
10 years.
It's 10 years. It goes down, interest rates go up by 1%. How much the bond will lose?
Duration
Exactly.
times bond value times
Exactly.
Times 100.
and no, times 100. How much you said the?
Yeah, exactly. It's worth, it's got a price of 100, so the value is equal to the notional. So it's going to lose
Times 100.
duration times
Bond value.
notional times value.
Times
and
plus.
If I say that the standard deviation of the interest rate move is 30 basis points, what is the standard deviation of the value of the bond in euros?
Say that again.
The standard deviation of the movement of interest rates is 30 basis points. Okay? So, interest rates are 5%, I have 1 sigma chance of going to 5.3%, 30 basis points. Okay? How much would the drop be in my bond value? 1 basis point, you got it. You said duration times notional
The same.
times price. Now I say 30 basis points.
Duration times bond value times 30 plus.
30 basis points. 30 basis points is 30 over 10,000.
10,000.
Okay.
Yes.
So, if this then is my 30 basis points, okay, then goes without saying that this, in the case of the bond, is my minus
Okay.
duration times notional times price over 100 times 1 over 10,000. Okay? And this is all you have to know. This is all you have to know to complete this, for this portfolio. I guess it's time to take a break. 5 minutes, and then we get back.